It says it's still host disabled participant screen sharing.
Oh, I'm sorry. Just
Yeah.
1 second. Here we go.
Okay. Okay. Hello, everyone, and thanks so much for joining us today. I'm going to be talking about my PhD research, bargaining competition and vertical mergers. So this is my PhD supervised by Professor Willem Boshoff. And this is, well, we initially thought this is going to be one chapter in the research, but it's a joint project with Professors Luc Frobe and Stephen Chonch at Vanderbilt University. But as it turns out with this type of research, this will probably be more, or the biggest part of 2 chapters of my thesis in the end. So with that being said, we have a lot to get through today. So I'm going to try and keep it as brief as possible. We simulate 11 models in this paper. So as you can think, there's a lot of mathematics behind what we do, but I'm really going to try and just give you an intuition behind what we did, how the models work, how we calibrated the models, and then really focus on what we learn about bargaining competition as well as substitutability. But by no means does that mean you're not allowed to ask questions about the models or the calibration or the simulations. You can stop me at any time or even email me on this email address you see on the screen now. So let's jump right in. Vertical models are built on really 4 parts. It's a network of upstream firms and downstream firms, and they bargain bilaterally in the presence of externalities that's created by the competition between downstream retailers and who's facing a consumer demand surface. So when we allow vertical merger, we combine complements which produce potentially anti-competitive effects, but only really through indirect mechanisms with many moving parts. This complexity was highlighted in the recent 2016 AT&T and Time Warner merger challenge, and it really highlighted the uncertainty surrounding the proper characterization of bargaining, and it spawned renewed academic interest in this topic. So with this paper, we recognize that vertical merger models is really a complex system, and it can, we argue that it can best be understood by simulating its effects. So we run a number of numerical computations and hopefully answer the questions: how do different assumptions about the nature of bargaining affect the predictions about the effects of vertical mergers, as well as how these results are related to measures of substitutability. So let's jump in with the models. So like I said, we simulate vertically related markets for 11 models. And with 3 of them, we allow a vertical merger. So we assume a 1/2 case, so that being 1 upstream firm that we denote firm A, and 2 downstream firms that we denote 1 and 2. In the 3 models of vertical mergers, we assume that vertical integration is between firm A and firm 1. So that would be then the vertically integrated firm, and downstream firm 2 becomes the rival firm. And then finally, all results are derived from an assumed nested ledger downstream consumer demand model for 2 goods: a product manufactured but sold, a product manufactured by A but sold through 2 different retail outlets, firms 1 and 2. Okay, so the first 2 models we call benchmark models. We calculate competition, which imagines goods being sold by independent firms. The upstream firm is taken to supply at cost, and downstream firms collect all the profits. So nothing new here. And then we also calculate the monopoly model, which imagines goods sold by a single firm. Downstream firms are taken as transparent, and wholesale prices are set above cost to induce monopoly level pricing, and fees are taken to return profits to the upstream firm. So having these results on all of our graphs is really helpful, since a vertical merger normally means a move towards a monopolistic market outcome. So it's useful to have that benchmark there to see where do we fall following a vertical merger. Is it closer to monopoly or closer to competition? Then we also calculate the more traditional, older derived demand model that you find in the literature. and this is our non-bargaining comparative model. Downstream firms take the wholesale price and they take it or leave it kind of scenario. They then determine Nash equilibrium retail prices, and then obviously the resulting retail demand defines wholesale demand for the upstream firms. And that's where the name comes from, derived demand model. And then also prices are then determined by upstream firm facing this derived demand in Nash equilibrium. Then we allow a vertical merger in this setting, and then as expected, the merged firm sets wholesale price to downstream firm 2. They then decide retail prices in Nash equilibrium, and the wholesale price to 2 is determined to maximize total profit of the merged firm given retail competition. So then this is our traditional derived demand model and also our benchmark model. Then we introduce bargaining, and the first type of bargaining is over linear prices. In linear prices, firms set marginal wholesale price so as to maximize the Nash bargaining solution. So for the Nash bargaining solution, we need a few components. Suppose without product 1, firm A would net a profit of pi star A, and firm 1 would profit pi star 1. And similarly, without product 2, we have these profits. And these are what we characterize as threat points or disagreement points. And that is used in the when pricing linear, firms A and 1 would negotiate and finally settle on a wholesale price so that the final profits that they make would maximize this bargaining solution that we find here, with these threat points plugged into this equation. And exactly the same when firms A and firm 2 settle on a wholesale price 2. They also maximize this Nash bargaining solution of this form.
Sorry,
so we use
clarify something. Sorry,
yes, sure.
So you have product 1 and product 2. So my understanding is that you have a monopoly upstream, and they sell, I suppose from this, they sell 2 products. There's product 1 and product 2.
Yeah.
And then downstream you have firms 1 and 2.
Yeah, so they require a necessary input for their production to produce their final good from the upstream firm.
Okay, cool. Thanks.
Okay, no problem. So then in this setting, we allow for 2 linear pricing bargaining models and 1 vertical merger. So the difference in these models in the setting comes in when we characterize these threat points, as I showed you here earlier. In the Nash bargaining solution, the threat points for a Nash-in-Nash linear pricing model, NI-in1, are assumed determined by the same wholesale prices as will be negotiated when both products are available. So in this equation, we assume that the threat point or the disagreement payoff takes the same wholesale price as they are going to negotiate over right now. But the refinement of this is the Nash-in-Shapley bargaining model, where threat points in the linear pricing are assumed to be recursive. So we also call it, they allow for contingent contracts or renegotiation. So the threat point for each agreement is taken to be agreement at a new wholesale price, satisfying a Nash bargaining solution for a single good. So just to be 100% sure, the wholesale price in this setting is different from the wholesale price in this setting when we bargain via the Nash-in-Shapley specified threat point. And then finally, in this setting, our third model is a vertical merger. And since we are working in a 1/2 setting, it's very useful that we then only have to consider the agreement between the vertically integrated firm and the rival firm following a vertical merger. And therefore, these 2 threat points boil down to exactly the same thing. And hence, we see exactly the same post-merger outcome for the Nash-in-Shapley and Nash-in-Nash.
So I just have a question.
Yes.
What is the motivation for considering these 3 cases?
So the Nash-in-Shapley is really a refinement of the threat point. So if I just go back to this, we don't find it very believable that if if firm A and firm 1 are negotiating over a wholesale price that and they don't come to an agreement, we don't think that the negotiation with firm 2 is going to remain constant. We think that they're going to say, but you didn't reach an agreement with this other firm, so we need to renegotiate the terms of our contract. So that's really the motivation for refining this Nash-in-Shapley thread point. So we think it's a more believable characterization of the real world. Does that answer your question?
Yes, thank you.
Okay. And then finally, the last setting that we look at is the two-part pricing. Now in two-part pricing, we again have this marginal wholesale price that we're bargaining over, but then we have an additional wholesale fee that we bargain for. So think of this as a franchise fee or a fixed fee that the downstream firms are to pay to the upstream firm. So again, in exactly the same way as in the linear pricing, the Nash bargaining solution maximizes the total surplus over the thread point. So the thread points are characterized as above for Nash-in-Nash, Nash-in-Shapley, and everything stays exactly the same, determining the wholesale prices, determining the retail prices. But then when we determine total operating profits, we then have this additional step where we have to say, how are we going to split the surplus? And that's where the fixed fee comes in. And so I say here, fees F1 and F2 are then set so the final net profits are a fair split over the thread points. And then the specification of how surplus is maximized further characterizes the different types of bargaining in two-part pricing. So again, we will have a Nash-in-Nash specified two-part pricing versus a Nash-in-Shapley specified two-part pricing. So for Nash-in-Nash, two-part pricing, we say that each surplus is maximized independently, assuming the other agreement is fixed. So this again relates to how we specify the thread point. When firm A and firm 1 is bargaining, they assume that they maximize their surplus independently, and they assume the agreement with firm 2 is fixed. And in exactly the same way, Nash-in-Nash quantity works also in that way, but bargaining is over a quantity and a total price for the good, and not just the wholesale price and the fixed fee. For a Nash-in-Shapley specified two-part pricing model, we say that total surplus, or what we also call grand coalition surplus from both agreements, is maximized. So firm A realizes that they are also bargaining with firm 1 and firm 2, so that they then maximize this grand coalition surplus. And in that way, the effects of other agreements are accounted for when they compute the surplus from an agreement. Okay, and then finally, we also allow a vertical merger in the setting. And then again, because we're only considering the upstream and 2 downstream case, we all of the models boil down to the same post-merger outcome, so that each of these have the same post-merger equilibrium. Okay, so I know that is a lot to take in. So just to summarize the 11 models that we have 2 benchmark models, monopoly and competition. Then we have non-bargaining models for comparison reasons, the derived demand, and we allow a vertical merger in derived demand. We have 3 linear pricing models where we bargain only over the wholesale price. That's a Nash-in-Nash, a Nash-in-Shapley, and both of them boil down to the same vertical merger model. And then we have 4 two-part pricing models. We have the Nash-in-Nash, Nash-in-Nash quantity, Nash-in-Shapley, and vertical merger. And that brings a total to 11 models that we simulate effects for. Okay.
Can I ask a question again?
Yeah, sure.
Because you started from very technical discussion, and also here you list all the models that you look at. But I lack motivation for why two-part pricing specifically. Is there a reason why you want to look at this? Or?
Yeah. So again, we find that a two-part pricing bargaining is more realistic than the linear pricing models, because when we're pricing linearly, and this will come through in the results that I'll discuss just now, we find that in a linear pricing model, we really don't have enough instruments to get all of our goals, to achieve all of our goals. And that's why we say we really bargain inefficiently when we bargain over linear wholesale prices. Because think of it this way: if you're an upstream firm and you have to set the wholesale price, that's the only way that you, by setting a lower wholesale price, you ensure that the downstream firms can produce a high quantity, and then the industry profit is increased. But at the same time, the wholesale price is the only mechanism that you have to get your share of that profit. So then you are likely to set the wholesale price higher. And these two goals are really in conflict with each other. And that's why we say you bargain inefficiently in the linear pricing setting. But in a two-part pricing setting, you have two instruments to achieve two conflicting goals. You can set the wholesale price a bit lower and thus increasing industry profits, but then you can recoup those profits and get your share of the profits by charging a fixed fee. So that we call two-part pricing really efficient bargaining. So that's the motivation for having linear pricing as well as two-part pricing in these simulations.
And the objective is to assess impact on welfare, or?
Yes, definitely. So the objective is to see what the differences are between linear pricing and two-part pricing, but as well as this different characterization of bargaining of the threat points and how surplus is maximized. So Nash-in-Nash and Nash-in-Shapley.
All right.
Okay. Okay, so then we move on to calibration. And again, so we have our 11 models, and we calibrate the model for two measures of substitutability. So then we have two sets of calibration, and this is important to take note of, that for the first set, we consider the substitutability of the inside goods with the outside good. So we exogenously increase the quantity of the outside good or the no purchase option in our larger demand function, and that increases aggregate elasticity in the industry. So that constitutes the first calibration of the 11 models. For our second calibration of the models, we consider substitutability between only the inside goods. And in this regard, we can use the nest strength parameter of the larger demand function, tau. If tau is equal to 0, we have a weakness and we have bad substitutes. And when we increase tau to 1, we have a strongness, and the inside goods are good substitutes for each other. So for these two calibrations, we also assume the same set of primitives that calibrates the models. We fix the scaling parameter in our larger demand function. We set the initial prices to 10. We set our initial quantities to 50. And we set the marginal cost of the upstream firm to 0. Then the remainder of our variables that I'm going to show you now are calibrated to the monopoly equilibrium, and they yield different initial parameters for our two measures. So just keep in mind that we are fixing these parameters for both our calibration sets.
So I'd like to ask a question. So maybe it's a boring question, because I will ask pretty much the same about the previous slide. So again, what is the reasons for these two different cases that you consider on demand on the previous slide? And
so it's because we have these two measures measure a different type of substitutability. So you will see just now, maybe I can skip to that.
What specifically do you want to achieve by having these two cases?
We want to say something about own price and cross price elasticity and the effects that they have on vertical mergers. So for aggregate elasticity, for our first calibration, we have own price elasticity increasing, but cross price elasticity decreasing. And that's because we increase aggregate elasticity in the market. So this is a different calibration to the second one, which I'm going to get to now. Just quickly, I just want to mention as well that the marginal cost is also increasing because we're increasing the substitutability, which indicates that profit margins should decrease. But remember, because we are fixing our initial prices, that means that marginal cost is going to increase. So,
but what does it mean? So what does it mean for the type of markets that you consider? Like, what I'm lacking is some motivation, which is maybe more practical. Like, what does it mean that you consider this higher share of outside option, or say, or
so it's not necessarily the higher share of outside option. It's more in regard to the aggregate elasticity. So when we are presented with a merger case, we can go and look at the industry and say, the industry is likely to have low aggregate elasticity, or it's likely to have high aggregate elasticity. And you will see in a moment on the graphs that for a high aggregate elasticity versus a low aggregate elasticity, we may find that the merger is either pro-competitive or anti-competitive. So the merger effects are also dependent on the elasticities.
so it depends on the aggregate elasticity on the downstream market.
Yeah.
But if you go back to your slide on the demand, so
this one,
no, the one before. So because you calibrate the model, then you also choose the parameter alpha. I mean the price coefficient in your model. Sorry, I mean the next slide. The next slide.
Yeah.
It's because you say you use a nested logic model, right?
Yeah.
And you, in the first case, you choose the inside good with the outside, substitutability of the inside good with the outside good.
Mm-hmm.
And the way it's chosen is by means of which parameter, how is it chosen actually?
So exogenously increasing the quantity of the outside good or the no purchase option in our logic demand function. And when we increase that outside quantity, because we're calibrating the model to every set of, to each row of our initial parameters, that produces an increasing aggregate elasticity. When we say move from the outside quantity of 20 to 21, that increases our aggregate elasticity.
So in other words, does it mean that you increase the market size or something like this?
Only of the outside option, the no purchase option.
Right, but if people choose between two goods and the outside option, and you increase the size of outside option, then technically you increase the number of people choosing something else. So you kind of increase the market size. And my question was related because you suggest that the size of market outside option impacts the aggregate elasticity based on the formulas from logic model. But why do you do it specifically in this way, and what is the motivation? Because the same thing can be achieved by changing parameter alpha, which is the price coefficient. Essentially, you can make demand more or less elastic without manipulating the size of the market. So I wondered, like, what is the motivation for, and what does it mean that you, because it seems to me like that you change the market size, and it's not clear to me where it comes from.
I could be wrong, but I think we chose to do it this way because of the way that it impacts our other initial parameters. The fact that it then also affects own price elasticity and cross price elasticity.
Right.
So if we only played around with alpha, then that wouldn't affect own price and cross price elasticity in this way.
Right. Well, I'm not sure, but maybe it will be clear later.
Okay. I'm going to move on to our second calibration then, where we use the Nash strength parameter. And when we increase the Nash strength parameter, we see that cross price elasticity gets more elastic, and own price elasticity also gets more elastic because it's we take the absolute value. So it's important to note that for this calibration of our models, the elasticities are moving in the same direction, while as previously it moved in opposite directions. For the net strength parameter calibration, we also keep aggregate elasticity constant, and that's why the marginal cost remains constant for all values of the net strength. Okay, so just to recap, we have 11 models that we calibrate to two sets of parameters. We have the net strength parameter and we have aggregate elasticity. So from these simulations, we can learn a lot about elasticity effects, but more importantly, we can also learn a lot about bargaining and vertical mergers. So because it would be repetitive to only discuss the effects that we see in the aggregate elasticity simulations and then discuss the results that we see in the net strength parameter simulations, we group the lessons that we learn about bargaining into the first section of our results. So I'm going to show you both of the graphs for the net strength parameter as well as the aggregate elasticity to show you the lessons that we learn about bargaining in this regard. So just to start from the beginning, the benefits of working in this 1x2 bargaining setting is that we only have to consider the agreement between the vertically integrated and the rival firm post-merger. And like already mentioned, this renders the Nash-in-Nash and Nash-in-Shapley trade points equal, so the post-merger equilibrium for both firms are equal. And this really enables us the analysis of some key differences in Nash-in-Nash and Nash-in-Shapley that would otherwise not be observable. So just quickly, what do we know either from the literature or from our pre-existing knowledge? And I'm going to skip a slide and show you how these graphs work. So here I show you the downstream variables for our simulations over aggregate elasticity. We have, for example, when we look at the quantity of downstream firm 1, we have 3 panels for every graph. The first panel shows you the benchmark models, the competition locus, monopoly locus. We have the derived demand locus, and then the arrows pointed towards how the vertical merger in that setting looks like. So that's the derived demand panel, and aggregate elasticity at monopoly is here at the bottom, and the second axis, x-axis at the top, is just cross price elasticity. Then in the middle panel, I show you the linear pricing or one-part pricing. We have Nash-in-Nash, we have Nash-in-Shapley, and then we have the vertical merger arrows pointing towards the post-merger equilibrium. Recall that it's the same for both of these models. Then in the final panel, I show you two-part pricing. We have Nash-in-Shapley, Nash-in-Nash, and Nash-in-Nash quantity. All 3 of them move to the same post-merger outcome. And just for consistency, in all panels, the vertical merger models are shown in purple. Nash-in-Nash is shown in green, and Nash-in-Shapley is shown in yellow. Nash-in-Nash quantity is in orange. So what do we know about merger effects? So we know that when the upstream firm and the downstream firm merge, that increases the quantity post-merger for the vertically integrated firm. That is observed in all of our models of vertical integration, arrows pointing upwards. We also know that the price for the vertically integrated firm decreases post-merger. Well, for some models, and I'm going to get to that in a short while. We also know that for the rival firm, quantity decreases post-merger, arrows pointing downwards for all of them. And we know that the price for the rival firm increases post-merger. And like I said, these are the simulations for aggregate elasticity. I can show you exactly the same effects for the simulations over the net strength. Quantity 1, quantity 2, downstream price 1, downstream price 2. The reasons that we see this is because of the well-known phenomena of elimination of double marginalization. Here I show you the wholesale price of firm 1. You can see pre-merger for derived demand, Nash-in-Nash 1, Nash-in-Shapley 1, and the same for the two-part. However, we do not observe any wholesale price post-merger because of elimination of double marginalization. Firm A and firm 1 merges, and that eliminates this wholesale price 1. However, in contrast, wholesale price 2 post-merger is increased because of the well-known phenomena of raising rivals' cost. And these two effects drive the results that we see here, the effects on quantity 1, price 1, quantity 2, and price 2. So there's nothing new here. This is what we expect to see when we allow vertical mergers. And like I said, exactly the same effects are observed for the Nash-strength calibration. Then just quickly, total merger effects. Here I show you total quantity, quantity 1 plus quantity 2 for aggregate elasticity. And I also show you total quantity for the Nash-strength parameter. When we look at the derived demand panel, we see that total quantity in the market increases for all levels of either elasticity or for Nash-strength parameter. So that really highlights the problem with this traditional derived demand model, in that the elimination of double marginalization in these models is so big, it always outweighs the raising of rivals' cost, so that we can only find for a pro-competitive merger in the derived demand setting. So that's what we already know from existing literature. So let's go on and introduce bargaining into for our models. And this is just a summary slide. We bargain over linear wholesale prices. The retail prices are determined in Nash equilibrium. And we know now how to specify these spread points, Nash-in-Nash and Nash-in-Shapley, with Nash-in-Shapley allowing for renegotiation and this contingent thread point. However, despite the differences in how we characterize these thread points, the two models show very similar results for all of our variables of interest. So let me show you that quickly. In the linear pricing setting, so we're again at aggregate elasticity simulations, we see that Nash-in-Shapley and Nash-in-Nash are very close to each other for all of our variables of interest. And I can show you for wholesale price, and I can show you the same for the Nash-strength parameter. And the reason for this is what I already alluded to earlier, is that in linear pricing, we have only one instrument or parameter to achieve two conflicting goals. These two conflicting goals being the upstream firm wanting to increase implicit profit and thus being inclined to accept a lower wholesale price. But also, the wholesale price is the only instrument it has with which to take its share of that profit. And then we see that this really diminishes the differences in thread points in linear pricing. So that it almost doesn't matter if you specify Nash-in-Shapley or Nash-in-Nash in linear pricing. Then just the last thing I want to mention for linear pricing is that observe how when we introduce bargaining, we lower the wholesale price in comparison to the derived demand setting, because the downstream firms are not in the scenario where they have a take it or leave it option of the wholesale price, but they can bargain over the wholesale price. And that's why we see a lower level of the wholesale price at every level of aggregate elasticity. And that's the same for our simulations over the Nash-strength. Okay, then we get to two-part pricing. And here we see that thread points really do matter in the two-part pricing world. Again, I already covered all of this. Just quickly, this differentiation about how the surplus is maximized. Nash-in-Nash, each surplus from a bilateral agreement is maximized independently, where the Nash-in-Shapley maximizes grand coalition surplus from both agreements. And what do we learn about bargaining in a two-part world? Well, we see that the Nash-in-Nash is more competitive than the Nash-in-Shapley outcomes. More specifically, the Nash-in-Shapley outcomes correspond directly to the monopoly outcome. And let me show you that quickly. Here we see quantity 1, for example, the monopoly, and Nash-in-Shapley exactly corresponds to that. And the same for prices and for wholesale prices as well. And that's the same for the net strength. And this follows exactly from the way that we characterize bargaining in the Nash-in-Shapley case. Like I said, total surplus from both agreements is maximized, and the effect of the other agreement is accounted for in the calculation of the surplus. So recall that our system is calibrated to the monopoly equilibrium, so that the monopoly quantities and prices are exactly those that would maximize total surplus. And like I said, contracts are contingent and allow for renegotiation, so players can commit to the higher monopoly price and lower monopoly quantity. The Nash-in-Nash bargaining in two-part pricing corresponds to a more competitive outcome. Pre-merger quantities are higher, prices are lower, wholesale prices and wholesale fees also correspond to a more competitive outcome. And again, we explain this by the way that bargaining is characterized in this model. And I already mentioned this. It's from how surplus from a bilateral agreement is maximized independently. Okay, so what does that come to then? When we look at total merger effects, again, I'll show you total quantity for the aggregate elasticity calibration, and I'll show you total quantity for the net strength calibration. We see exactly the same thing. We see Nash-in-Shapley total quantity increasing following a vertical merger, same year, but we see the Nash-in-Nash total quantity decreasing following a vertical merger. So we find a pro-competitive merger for Nash-in-Shapley, but an anti-competitive merger for Nash-in-Nash. Let's see why this is the case. For the Nash-in-Nash, we say that the low costs drive the merger effects. So the Nash-in-Shapley two-part pricing models show the lowest total marginal cost. Total marginal cost being marginal cost plus the marginal wholesale price. And as you can see, that's the lowest for all of our models apart from competition, of course. And the same for the net strength parameter here. And like we already said a few times now, that's because the upstream firm consists of two instruments to achieve its two conflicting goals. When we allow a vertical merger then, the same principle applies of two instruments, and we see that the two-part pricing total marginal cost is also the lowest for all of our models of vertical integration. So we say that because of this very low starting point, and even though it's a very low post-merger total marginal cost as well, the raising of rival cost starts at such a low point and increases to this level that still outweighs the elimination of double marginalization, which is also a bit smaller because of this low starting point. So that's why we see there's always anti-competitive merger in the Nash-in-Nash two-part pricing setting. For the Nash-in-Shapley merger, it's interesting that we are actually moving away from monopoly, which is weird because when we allow a vertical merger, that means normally a move towards a more monopolistic outcome. So post-merger, the elimination of double marginalization of the pivotal player occurs, but then it also inherits the marginal cost from its vertically integrated downstream firm. And then it acts as if this and not the transfer price is its true marginal cost. And this then makes that the vertically integrated firm cannot credibly commit to the price at the monopoly level anymore because of this change in its marginal cost. Then on the other hand, the rival downstream firm's total marginal cost is partly determined by the negotiation with the vertically integrated firm. And all of these effects combined causes, and the fact that the raising of rival's cost in the Nash-in-Shapley case is not as big, results in always finding a pro-competitive merger for the Nash-in-Shapley models. Okay, so that's all the lessons that we learn about bargaining in our simulations over either aggregate elasticity or net strength parameter. Let's shift the focus now towards our simulations over only aggregate elasticity. And recall that an increase in the outside quantity increases aggregate elasticity, but we render the demand for products effectively independent. and causing a decrease in cross-price elasticity. We thus expect to see substitutability between the inside goods to decrease, competition to weaken, and firms being able to charge a higher price and decrease their quantities. These effects are all observed in these graphs, with quantity being a decreasing function and prices being an increasing function of aggregate elasticity. Following a vertical merger, we see that downstream price of firm 2, the relation to aggregate elasticity changes. And I show that here on this graph, where pre-measured was an increasing function. We see now that for the derived demand, it's basically constant. We see that for a linear pricing, it's slightly decreasing, and for two-part pricing, it's decreasing, a decreasing slope. And we explain this by the relationship to total marginal cost that firm 2 faces post-merger. In the derived demand, we see that total marginal cost is pushed right up towards the initial price that the system is calibrated to. In the linear and two-part pricing cases, marginal cost is not as high, but the raising of rival cost still occurs. However, the rival firm has more space to act on its increased own price elasticity, and therefore it decreases its price as the aggregate elasticity increases and gets a bigger share of the market as the aggregate elasticity increases. Just quickly, the total merger effects, total quantity and aggregate elasticity, we see that the linear pricing panel is the only panel where the effect of the merger is reliant on the elasticity in the market. We find that the merger is anti-competitive for low elasticity. It reduces total quantity in the market, but it is increasing total quantity pro-competitive for high elasticity. And this is simply explained by the raising of rivals cost effect outweighing the elimination of double marginalization for the anti-competitive effect, and vice versa for the pro-competitive effect. Okay, and lastly, I just want to discuss a few things about the simulations of the net strength parameter. In contrast to the previous section, cross-price elasticity is now increasing in our substitutability parameter, so that we expect prices to be a decreasing function, quantities to be an increasing function, and the wholesale prices to be an increasing function of the net strength as the upstream firm internalizes more and more competition. So we observe all of those effects apart from the wholesale price for the linear pricing setting, where we see wholesale prices being a decreasing function instead of increasing function of the net strength parameter. So again, this idea of the upstream firm having only one instrument which to achieve conflicting goals comes in. And in this case, the upstream firm is accepting a lower wholesale price as the net strength increases in order to increase the industry profits. And even though this might seem counterintuitive when we look at the profit of the upstream firm, it is taking a bigger share of that profit as the net strength is increasing. So that this is not counterintuitive in the end. Post-merger, we observe all wholesale prices being an increasing function again, and this is just because the incentives of the vertically integrated firm changes. It no longer has the incentive to internalize the competition between the vertically integrated downstream firm and rival firm. And then as a result of the raising of rivals cost, post-merger price of downstream firm 2 significantly increases and the quantity decreases. The vertically integrated firm increases its price towards the monopoly price as it gains an increasing share of the market by raising the rival's cost as the net strength gets stronger. So that's just explaining this increasing downstream price 1 and decreasing quantity of downstream firm 2. And then all that remains is to explain post-merger total merger effects for net strength. Again, the only panel that's reliant on the changing parameter at the bottom is the linear pricing panel. Here we see an anti-competitive merger for a strong net total quantity decreasing in the market, and we see a pro-competitive merger for weakness, total quantity increasing in the market. And again, this is explained by raising of Robert's cost effect outweighing the elimination of double marginalization, and vice versa for pro-competitive merger. And then it's also nice to note that this result corresponds with the results for aggregate elasticity, in that a vertical merger is pro-competitive the lower the cross-price elasticity is. So at this side, we have a low cross-price elasticity, but high, and this side a high cross-price elasticity. And here we find a pro-competitive merger, which is exactly the same that we found here. For high cross-price elasticity, we find an anti-competitive merger, and a low cross-price elasticity, we found a pro-competitive merger. Okay, so just to conclude, we recognize that vertically related markets really represent a complex system with many moving parts, and it becomes even more complex when you allow a vertical merger. We attempt to unpack this complexity and identify the drivers of competitive effects by simulating vertical mergers. And these simulations show us how the assumptions that we make about the nature of bargaining, as well as the substitutability of goods, affect our predictions. We show that refining the specification of threat points that characterize bargaining has little effect when firms bargain over linear wholesale prices, but these differences are really highlighted in a two-part pricing bargaining scenario. We also show that Nash-in-Nash is more competitive than the Nash-in-Shapley bargaining in a two-part pricing setting, and that the results in a vertical merger in Nash-in-Nash is always welfare reducing, while the Nash-in-Shapley is welfare increasing for a two-part pricing setting. Finally, relationships between elasticities, prices, and quantities are important in the simulation of vertical mergers. We identify costs as a major driver of the outcomes in vertical markets. Because vertical mergers change the cost structures in markets through the elimination of double marginalization and raising of rivals' costs, we find that these relationships can change after a vertical merger. This is most clear in a linear pricing setting, where the competitiveness of a vertical merger depends on the substitutability. And as I just mentioned, the merger is pro-competitive when the outside good is a good substitute for the inside goods, and when the inside goods are bad substitutes for each other, and a merger is anti-competitive when the outside good is a bad substitute for the inside goods, and when the inside goods are good substitutes. And that's all that I have to say for today. Thank you so much. I'm looking forward to comments or questions.
Thank you very much for the presentation, and we have time for some questions. So feel free to raise your hand and ask a question. Okay, if there are no questions, I already asked some, but I can ask some more. So it's still not clear to me, maybe I don't remember the slide, in terms of all the parameters that you use in your simulations. Can you please again repeat which parameters are this? So in the nested logit model, there are essentially two parameters, right? Which is a sigma, the degree of substitution between inside goods, and as I understand, alpha as well, which is the price coefficient. Is correct? And then also costs or something else?
Yeah, I'm actually not sure at the moment, because we're able to calibrate these models to any demand function that we like. It's just easier to use this logit demand function because of the snare strength parameter that we can increase and get a set of calibrations to simulate our models.
Right. So why specifically you chose nested logit model and not linear demand model or something like this? Precisely because you want to have inside good substitution versus outside good, or? Yeah,
exactly that. So because to play with this net strength of how good substitutes the inside goods are to each other.
But again, I mean, it's not very clear to me and maybe I just don't see this in detail. Maybe in the paper you have outlined the model itself. But as I said before, so I understand that there should be like two parameters on the demand side downstream, which is alpha and the substitution parameter. And both of them are impacting the elasticity of demand, so own and cross price elasticity and the aggregate elasticity. So it's still not clear to me why these parameters are not changed. So you change the sigma, the nesting parameter, to increase or decrease substitution, but in order to impact the aggregate elasticity, you change the outside good size, right? And it's not clear to me why this is needed, because I think it can be achieved by alpha price coefficient. But in any case, it's also not clear to me in terms of interpretation, because your presentation was very technical in a sense, showing all the impacts on the output variables. But so what does it mean? Like technically increasing the size of outside good, how should it be economically interpreted in terms of specific industries? So I don't know whether you have an interpretation, or maybe it's something that should be added as a motivation for manipulating these variables in order to check how they impact the results. Do you have an answer to this? Like, why is it specifically interesting?
Sorry, I didn't hear that final question. The internet.
So what I mean is that you show that the results are sensitive with respect to aggregate demand, right?
Aggregate elasticity.
Aggregate elasticity. So why
Yeah.
is it interesting? Is it some, in terms of practical application? Is this a question?
Yeah. So it really is. So if we have a market that's really characterized by high aggregate elasticity, it matters whether we say that we assume that linear pricing or two-part pricing is present in this market, because that's gonna determine the competitiveness of your vertical merger if you assess that.
So so your recommendation with that respect is, when there are vertical mergers, then one should check what is the aggregate elasticity of demand downstream, because this impacts.
Yeah. In accordance and together with that, whether there's one-part pricing or two-part pricing in these markets.
All right. And another question I have with respect to Nash-in-Nash and Nash-in-Shapley. So why do you look at these two cases?
So it's because the Nash-in-Shapley is a refinement of the Nash-in-Nash bargaining solution. It's that we have this recursive thread points in the Nash-in-Shapley that's more believable than the Nash-in-Nash thread points.
And is there any practical connection between these two types of bargaining?
What do you mean by
practical connection? In a sense, so you say that your results are in some cases sensitive with respect to this, right? And whether, say, if a vertical merger is investigated, is this type of bargaining one of the questions that should be looked at, or?
So it's not necessarily the type of bargaining that should be looked at. Is how we model bargaining. So do we think that when firms bargain, they regard all other agreements that they think of as fixed, or do they think that those can be renegotiated if a certain agreement is not followed through? So it's a refinement of how we model bargaining. It's not necessarily do we think that firms bargain Nash-in-Nash or Nash-in-Shapley. It's just a refinement of how we model bargaining.
All right. Okay, I just have one more question. So you didn't make really many references to literature, and you say that your results are in line. So some of the results were in line with literature.
So the results for derived demand is exactly how we find it in the literature. However, the Nash-in-Shapley bargaining solution is really a very new solution that Professor Luc Fripp is yet to publish in the proof of the existence of a Nash-in-Shapley bargaining solution is yet to be published. But we are busy working. He's busy working on that, while I'm busy working on the simulations to get that through to see how the Nash-in-Nash and Nash-in-Shapley bargaining differs. So we have, I still have to go and look at the Nash-in-Nash literature and say, and see whether these results are in line. But I do know that for the derived demand, it's exactly in line with what we find in the literature.
So if you were to summarize the contribution of your paper, then what
Yes.
it would be?
It's that it is important to see what the unverifiable assumptions about bargaining, how they affect the predictions of vertical merger models. And especially if we characterize it as a two-part pricing or one-part pricing bargaining. Because if you walk into a courtroom and you assume linear pricing, then it doesn't matter really how you characterize your threat points. But if you're in a two-part pricing setting, then that really matters, because we have an anti-competitive merger almost built into our Nash-in-Nash models, which is the existing models. But with this Nash-in-Shapley model, we have a pro-competitive merger. So we really, the contribution of this research would then be to say that it's really important to assess the assumptions that you're making about bargaining on a case-by-case basis when you're working with vertical mergers.
Right, and it's I'm sorry, I don't know much about Nash-in-Shapley bargaining, and so it is a more realistic approach. Is it the Nash-in-Nash, and why is it so?
I think it's a more realistic approach. The Nash-in-Shapley is a more realistic approach because it's this contingent contract. We say that if you're an upstream firm and Willem and I are downstream firms, if you and Willem don't reach an agreement, then the agreement that we're going to bargain over really changes, because then we can capture, especially in this setting, we can capture the whole market. So to think that wholesale price that we're going to agree over is going to be the same, regardless if you reach an agreement with the other downstream firm, is, according to me, actually unrealistic. So the Nash-in-Shapley allows for that renegotiation. It's a contingent contract. If you do not reach an agreement with the other downstream firm, that changes the terms of the contract that we're going to sign.
All right. Thanks a lot. So is there anybody else who would like to ask any questions? I'm sorry that I asked those questions, but nobody raised hands. All right, I guess there are no other questions, so we can finish at this point. And thank you very much for interesting presentation, and good luck with finalizing the project and looking forward to having it published. In the next week, we'll have another presentation by Onkame Motobi from University of Botswana. He will present a paper on mobile phones and financial inclusion in sub-Saharan Africa. So you will get an invite, and further information about next seminars will also follow. Thanks a lot, and see you next week.
Thank you.
Thank you, guys. Thanks, everyone.